Let me just check. So hey guys, I hope you're doing good. Let me just check quickly if my audio input is correct. Yo yo. Okay. Cool. Oh my god, that's. I was afraid at first. So yesterday we reviewed a couple of things. So we reviewed how dynamic lockup works, and this is what we created yesterday. I'll just give you a quick recap for those people who don't know much. So when we are creating, so there are two functions. First one is like once you can create from using duration. So duration is basically how much in what intervals you want what amount of money to be streamed. And the second function is like create with the timestamps, which is like the actual timestamps, right, rather the duration itself, right? So let's just talk about the duration. We'll take two inputs from the user, which is the create with duration, which consists of amount, exponent, and duration, right? Oh, sorry, that is segment with duration, but the create with duration is basically just a second. Let me just. Oh my god, why is it not working? Yeah. So yeah, create with duration is an struct which where you are liable to give details of the sender, recipients, deposit token, amount, etc., etc. And then it calculates the start time, which is like from what time. Since you are calling it right away, right? So the start time actually starts from the block that where you are calling this function, and then it creates segments based on like by calling calculate segment with timestamp. So remember that we are taking inputs of amounts and duration, and we are passing start time, so it calls that. And basically what it does is simply that takes the start time and just adds the duration itself, like from the duration, and adds to the start time, and based on that it creates segments. So segments is basically an struct here. I've already mentioned here. It's a struct which consists of timestamp and amount, right? So once it get back, it then declare. So it creates a timestamp where like a timestamp struct is basically start and end time, right? Even though we also have it under the segments, but we want to create a universal start time, so calculated separately. So we have lockup.timestamp, and then we are saving it to timestamps, and then we are calling create ld, which is just a second. I don't know what's going on. Yeah, it's working now. Yeah. So when we see create ld, right? So it's like the helper function is checking certain parameters and loading up the next stream, and then it is calculating the segments, which is consist of timestamps, right? Which we discussed here, and it is like pushing up segments under the stream id. So basically they have a mapping per stream id, which consists of segments with durations, and then it is calling create, which is just another function which just creates another array of mapping of an array. Basically we are mapping stream id to stream details, where every property is there. The question I'm confused here is like, what is the use for this timestamps, right? So timestamps is being passed as an argument to create ld, and timestamp is being passed here, and timestamp is being passed here, right? And is it being used here? I don't think so. Oh yes, sorry, here it is. When you are creating stream, you are calculating start time with timestamp and the other properties. Okay, right. And then you are basically calling mint on it, and that's just it. And like, you are creating an NFT of the properties of the stream. Just a second. Yeah, it's working now. Okay, yeah, so it's basically creating a stream. So now today we are looking into another type of lockup, which is I think linear. So from what I understand, linear is basically create lockup. Linear is basically like a straight line within a map, and should be relatively easy, but I'm confused about what is cliff here. So let's understand what is cliff, right? So we are so there's a function called create duration ll, which is lockup linear, and it is taking create with duration, which is should be like, okay, it is basically the parameters of the stream, what the token and details. It is taking unlock amount, which is a struct encapsulating the unlock amount for the stream. The sum of start and cliff must be, so the sum of start and cliff must be less than or equals to the must be less than or equal to the deposit amount. Both amount can be 0. The sum of start and cliff must be less than or equals to the deposit amount. Why? So, oh yes, of course. That's stupid of me. So they are saying that but what's the cliff here? Let's just start understanding it. Where was I? Here. And then it is taking duration, which is like wait a second, it's like the same thing, right? Oh no, its duration is basically the cliff and the total, whereas unlock amount is the start and the cliff. Okay, let me just memorize it. Unlock amounts is basically start, and the cliff start to like, I think it is like how much amount is unlocked at the start time, and how much duration you need to wait, and then start streaming. This is what I understand. Let's see, struct encapsulating the cliff duration and the total duration. Then okay. Let me just close it. Okay, let's just run around and we'll get back to later. So just a second. Unlock amount is having start and cliff, and duration is having cliff and total. Start and cliff, I'll just take a note of here, start and cliff, and it is having start and total, right? Is it right? Total, yes. Sorry, no, cliff and total. Bad. I'll take it. And then we are trying to create start and end is 0. Does that mean 0 is basically infinite? I'm not sure. Okay, cliff time is cliff time, and calculate the cliff time and the end time. So we are calculating the cliff time. Duration dot cliff, duration dot cliff is greater than 0, then cliff time is basically timestamp. timestamps dot start plus duration dot cliff. Okay, timestamp cliff timestamp dot n equals to start duration. Duration dot cliff is if duration dot cliff is greater than 0, then cliff time equals to timestamp dot start timestamps dot start duration the duration, how much the duration of the cliff needs to be. Okay, and timestamp cliff, so we are saving it into cliff time, and then we are setting the timestamp end to timestamp start plus duration. I think it will be like the cliff time is basically how much I am not pretty sure. Let's understand. Okay, so the cliff time is basically the moment after the start time when the token starts unlocking, right? So here we are taking start time, okay, which is okay, what's the time right now, and we are not like end is basically we are not certain about, right? So and then we are declaring a cliff time, and then we need to understand like from the time right now, right, to what time in the future would the cliff last for, right? So we see that start and cliff, I think, unlocks amount or duration. Okay, duration, let's take. So if duration dot cliff is greater than 0, then the cliff time is start, that is the right time right now, plus the what time the cliff is, and like it could be in like 30 minutes or whatever, and then we have set it to cliff time, and the that is cliff time, right? And then we are we have declared cliff time here, but we are not using cliff time anywhere here in the timestamp. So we are declaring timestamp dot start, and which is duration dot total, duration dot cliff and total. Okay, so we calculated the timestamp, which is the timestamp right now, what is the time right now, plus how long it needs to last, right? And then we are calling create LL, which should be straightforward, right? Model, then transferable. Yeah, we have gone through this earlier as well. So what is unique about is that uh, create no, we haven't gone through this. Lockup linear, wait a second. LD greater than this. What was the function we're calling here? Create LD, okay. And then we were calling create LD, which will then call create, right? And here calling create LL, and which will call create, and create has model lockup model details. Okay. Okay. So where were we? And then we are calling create LL with the parameters. Cliff time is how much time the user needs to wait for the stream to start, and we calculated by taking. So there are two important array here. So unlock amount is encapsulating the unlocks for the amount to be unlocked at the start time, want to be unlocked at the cliff time. Okay, I think my understanding is different. I believe yep. So unlock amount is basically how much unlock the tokens will get unlocked at the start time, and what amount of token will be soon unlocked after the cliff, right? And duration is basically how long the total stream would last, and how much the cliff is from the start time. Got it. And yep. So yeah. So and then once we calculate the cliff timing and the total end timing from the current time, we'll just calling create LL with the parameters cliff time, and everything remains the same. Deposit amount, recipient, sender, shape will be, I guess, oh, that's weird. Shape is okay in within the params, right? So it should be their string. Okay, and then we are taking tokens, address transferable or not. Unlock amounts is basically a struct which is what will unlock its start. And okay, that's straightforward. And this is using durations, right? And this is using timestamps, so we can provide actual timestamps where so in the earlier function with duration, we needed to calculate at what time in the future, in terms of seconds, we need to adjust the cliff, right? But here in the timestamp, we are expecting the user to provide the actual timestamp in the future, where they want us to unlock the unlock time, sorry, unlock amount, right? So previously we took unlock amounts and durations, and here we are only taking unlock amounts, since duration basically consisted of the cliff and the total. This is weird. Oh, sorry, no, we were calculating using this, right? And this is amount, this is the duration in seconds, right? So now we don't want, because the user will provide the that, right? But the thing is, what is cliff time in should be yeah, should be that only. It'll be the like added upon the timestamp, right? The cliff time is just second, cliff time, so the start and the cliff stream ID start and yeah, I was right. So it's just taking the time of the cliff in the block in like in the future, and it's just calling ll. So previously we used to calculate what is the current time, and we took a struct which says what is the end time and what is the cliff time, right? And then we'll add up to the block timestamp, right? But here we are not taking that, we are just taking cliff time. But other question here we need to ask is like how we are supposed to know what is the end time. Commands. That's interesting. Create LL. So now let's understand create LL. So it's like, okay, it's like doing something. We are not interested in looking right now. So we are like loading stream ID, and we are setting we like, since we get the stream ID, we are setting up the unlock amount, which is like unlock amount is basically the start and the cliff. The cliff is amount to be unlocked at the cliff time, right? So we are setting up what are the amounts that needs to be set at the start, and what needs to be unlocked by the start of the cliff, right? This is one thing. And then we are like updating the cliff time for the stream, and cliff time is basically cliff time here. Wait a second. So it's u into u int 40 mapping. Is it right? And then we are uint, and then we are saving a uint 40, and then we are calling create, which we looked into it earlier. Let me just fetch it. Function underscore create. Yeah, so we are taking stream ID stream, and the property that I'm interested in is looking as lockup model, which is either linear dynamic trenched but linear, this will be linear, right? So we are passing, wait a second, where was it? We are passing, wait a second, no. Where was it? Lookup model. I don't see. Yeah, okay, so we are passing linear here, and then everything remains the same, right? Okay, and then we'll mint it automatically. Yeah, so the question I wanted to ask is so cliff time, like after cliff time, the stream, after the cliff time, the stream is supposed to be closed, since what there is timestamp parameter, right? So when running here, so yeah, we are calling timestamps parameter. So params is having, so I create all params, shape and all, and we'll have params timestamp. We are calculate, no, that is, sorry, here create timestamp, create with timestamp, and then we are calling with param timestamp. It's not, it does have, yeah, it does have create with timestamp, and it does not have end time and stuff. Okay, cool, I understand now. The basic difference is basically it has timestamp, it does not have, since we are calculating it on the fly. However, in this where was it, sorry, in the lockup linear, the create ll duration does have a parameter, so we are calculating timestamps. However, in the create with timestamps, we are not calculating we're not calculating it on the fly, but rather we are expecting the user to provide it under here. So it does have the information about the start period and the end period, right? So this is how we are doing linear. Let's move on to the next module, which is, this is lockup state. Cool, let's just dig into it. I wasn't sure whether entrenched, why is it under abstract contracts? Hmm. Never mind. Aggregate amount. It has a mapping of token to amount. I think aggregate amount is like how much amount of tokens are available in that contract, right? Mm. But yeah, let's just read it here. Retrieves the aggregate amount across all stream denoted in. Okay, this is fine. My assumption is right. A native token. What the hell is native token though? Retrieves the address of the yes. Okay, I'm not pretty sure what um, for what reasons we are using native token. Next IDs, next stream ID is basically something that we have seen earlier. It is used to push the stream uh, in certain mappings, right? So it acts as a key. NFT descriptor is an address, and we have a mapping called allowed to hook, where we see if somebody is like creating some basically somebody is trying to create a stream. So if they are like allowed to hook, and then we can basically like the contracts will call the hooks on the streamers, like the one creating the stream will call, like the protocol will call their hook. And the cliff time is basically what we have seen. So stream ID, what is the cliff time, like at what time the cliff will start? Yeah, by what time the cliff will start. uh, yeah, which is that. 1 second. Gotcha. So I'm confused about, like, if here, like, we are defining cliff time, right? So like, will it go linear after the the cliff time, or will it go like up down, dynamic? Which is something that I need to look into. So stream starts at T0, unlock time is 100 tokens, unlock amount start, instant start, cliff 50 tokens, instant date, cliff duration of the cliff is 1 day. Did we wait a second? Let's see, duration of the cliff, right? Okay, so this is cliff duration, not cliff, right? Okay. So cliff time is basically a period where some amount of token is actually released as a cliff, but apart from that, um, the the stream remains constant. Okay, where were we? Right here. Then we have segments. Segments consists of like different amount of money for different amount of like time. This is what the segment looks like, and then we have ID, which is like stream ID, I believe. Yeah, streams mapped by the unsigned, and we can look into the data of streams. Where was it? No, not this one. Stream here. Weird, that's weird. Yeah, here it is. So address start time as cancelled, was cancelled and all. So here lockup stream map, lockup. This is tranched. We haven't gone through this. Unlock amounts is used. Okay, it's for tracking of time, not linear. We haven't gone through this, and I'm confused about this streams map. What it is used. So we understand that this unlock amount is basically how much time like, so we get segments, right? We get streams, which I'm trying to like, okay, this basically tracks streams with the data of the sender, etc., and the properties, and it is independent to whatever it is basically, be it linear, dynamic, or whatever. They are all mapped here. Segments is basically a dynamic where they are streamed with the like this different segments. And then we have tranche, we haven't gone through, so I don't know much about it. But regarding linear, we have stream ID to linear amount. So unlock is basically sorry, here we go, unlock amounts. So unlock amount is basically how much at start and how, like, the amount to be unlocked at the cliff time and the amount to be unlocked at the start time, right? Yep. And then we set next stream to 1, get cliff time, streams, lock model, stream reward, else cliff stream. Yep. Get deposited amount, streams on deposited. Okay. Get in time is streams and time. Model, streams, get segments, and should be in the segments, right? Get sender, sender, get should be in the stream. Command streams, no commands. Yep. So these are like general state querying models or like functions. Yeah. Good thing. What about trans? Trans? I don't know much about it. Oh my god, like, it's very cold here. Just give me a second. Yep, and but these are like, trans is basically similar to linear, right? Okay, this should be very straightforward though. Where was it? Here. So we are taking params, create with durations, which does not have timestamps. So we need to calculate yes here, and transfer duration is the amount, the time difference in seconds between. So block dot timestamp plus the duration will be the exact time where we will be unlocking, right? So here, which one? Yeah, let me just remove it. Just also. Yep. So we are getting the start time. We are creating tranches. So same logic here. We are getting we are like building up tranches. Tranches times basically amount and the timestamp, amount and at what timestamp the amount gets unlocked, right? And then we are just basically putting up the amount and the start time plus the duration. So we are doing that. Where was it? Oh, here. And then we are creating timestamp, start time, and we are taking the tranches last tranche data. Okay, and we're calling create LD, and create LD just checks streams ID and then we are looping tranches. Stream ID push. Tranches is basically tranches is like amount and timestamp. We are saving amount and timestamp, then that this at this time this someone needs to get unlocked, and then we are calling create just this thing, and the lockup model is trans. Okay, quite straightforward. So we have gone through all the abstract contracts. Interfaces we can skip for now. The question is, we have gone through create. Let's go through withdraw. This is view, right? So we don't want that. So they expect us to pay. Check. Okay, we need to also check the type, right? Stream ID, the type will be saved in under the streams. So we are doing some nitty-gritty checks. Amount is stream ID, and then we are checking stream of, we are looking into the model, and then we are like calling this function. If not, then calculate. Yeah, okay, so every model has a different set of functions for withdrawals. Okay, I think I'm gonna take a quick pause, and I'll be back in the next video where we'll dive upon how things are calculated in terms of like different models. We'll take we'll go through each and understand how the protocol is keeping track of the how much the protocol owes the user, right? So let's see. One quick thing that I just realized is that like they are created, but let's just see the create function, right? Create let me just see the functions. Born, allowed to hook, cancel, multiple, recover, renounce, etc, etc. Create is here, but where are we using create at? We're not using create at all. But how oh yes, okay, my bad, I am stupid. So when we are doing create, right, so where is it? Create is here. We are transferring the token from message sender to address this. Yeah, I was basically confused with at what process the project was charging the user, but here we can clearly see that the tokens are here. After minting is done, we are transferring the tokens from the message sender to our contract, and basically this is how we take money from the stream creator, right? Okay, good stuff. And so now we have clear picture of how the three types of models within the Sablier works, and we have a clarity on how to create them. Then in the next stream we'll learn how withdrawal works, um, and how can we cancel, or like uh, we can spot anything, right? Basically. Okay, I'll see you later. Bye bye.